Hello, my name is Nayantara Arora, and I'm a sophomore in the Honors College and fire recipient this summer. In school, I'm majoring in neuroscience, and this summer I had the chance to work in Dr. Ulrich Meyer's cognitive psychology lab to explore the research question, does the breathing cycle modulate the orientation of our attention? So what do I mean when I say the orientation of our attention? Let me give you all an analogy. Imagine that you, like many have this past year, are going to take an open note exam for one of your classes. You have two options. You can rely on your memory to answer questions, which will give you a greater degree of fluency and probably speed with the material. On the other hand, you can use notes, which will help you with accuracy and confidence with your answers, but at the expense of time and a more stilted performance. Similarly, in a more general sense, an internal orientation refers to one accessing information from their memory from within, whereas external orientation is when one gets information from their environment, such as lecture notes during an exam, or how I am right now with speaker notes for a presentation. So what this study is really looking at is, to what degree does the breathing cycle, that is when we inhale and then we exhale, also modulate spontaneous exploration of the environment? Our hypothesis for this study is that the tendency to turn to the screen for information, that is to externally orient oneself, is increased during the breath intake phase and decreased during the exhale phase. This experiment was created on the basis that there is initial evidence from animal models that during breath intakes, our cognitive system becomes biased towards encoding information from the outside. This might be a phylogenetic trace from when we used odor analysis, our ancestors, to obtain key information about our environment when we inhaled. That's when you smell environmental information. So this experiment is really a first attempt to examine the unaddressed question of the relationship between breathing and attention to the outside world in humans. So I'll give a brief overview of the experiment so you can understand how we apply that to the study. We gave our participants a computer-based task, and what they saw on their screen was quite similar to what you see. In the task, there are cues in the corner of the screen which serve as their directions. The cues indicate which task out of two the participants must complete. Participants are able to earn performance incentives for speed and accuracy. The participant must respond using computer keys based on the following cues. The location cue up here means that the participant must respond to which square contains the arrow. The direction cue, right over here, means that the participant must respond to which square the arrow is pointing towards. The task at hand may change with a certain probability, which is why participants will want to be checking their cues. However, checking cues hinders speed, just like checking notes during an exam might hinder your speed. On the other hand, it guarantees accuracy. The way that we know when people are checking cues is measured by using an eye tracking camera. And remember, the only way a person knows for sure what task they need to complete is by checking the cues. So we are tracking that. As you may have assumed, the cues in the corners of the screen are an example of an external orientation. So to summarize, participants either rely on an internal orientation, which is a belief or memory of the last seen cue, or external orientation, which is when they refer to the cues in the corner of the screen to make a decision of which key to press. Our question is the breathing cycle related to when people do or do not check cues for the task? So here are some photos of the experimental setup. We're collecting data based on where a participant is looking using the eye tracking camera pictured right here. We are also collecting data using this breathing belt over here, which was recently developed at the beginning of the summer as a part of this study. And this measures a person's breathing cycle as rendered on the computer screen over here. In addition to this data, we also collected behavioral data, such as reaction time and rate of errors. The breathing device that I've mentioned was created and implemented specifically for this project. So the very first analytical step is to check if the device itself works and collects quality data, which it does, as seen by these graphs generated by the breathing device. And as you can see, this graph clearly shows inhales and exhales based upon chest and stomach movement over a given period of time. To reiterate the hypothesis, what we believe we should see in accordance with the hypothesis is a Q check in the red highlighted region, representing an inhalation, or for that matter, at every purple highlighted region, which is an inhale, we expect a Q check. I'd also like to talk about some personal takeaways that I gained through this research experience, which include learning how to run a MATLAB script, learning to run the technology that was involved with this experiment, such as using the breathing belt and eye tracker camera. I gained a lot of knowledge of following experimental procedures, especially involving human subjects, which I am very grateful to have gained ample experience with, especially during a COVID summer. And in the future, I have a lot to look forward to. I am looking forward to learning more about data analysis, and that takes me to next steps. So we definitely need to continue collecting data so that we can have a robust sample size for further analysis. Once we do have enough participants, we are going to match up breathing cycle data with recorded eye movements and include behavioral data. And once we've matched everything up, we plan to analyze whether there's an effect in location in breathing for Q checking and see if that supports our hypothesis. And we also are going to see if it varies across various experimental conditions. Lastly, you might be wondering, why is this research important or significant or exciting even? And the truth is that the results could have important consequences for our understanding of how information processing might change with our breathing pattern. For example, as we age, our breathing cycles actually become shorter. This increase in breathing rate may contribute to an increased reliance on external cues, which has been observed in older adults. Also, breathing exercises are an important component of many meditation and therapeutic processes. So our work might provide a new understanding of how such exercises work, why they're effective, and allow us to propose interventions based off of the data collected. And lastly, I want to extend a very special thank you to the members of this lab who really helped me from even before the summer began to the very end. Literally could not have done it without you. Dr. Meyer, Min, Dominic, and Melissa, thank you so much. As well as thank you to Cure for allowing me to spend this entire summer gaining a very new research experience. I'm very grateful for the opportunity. And thank you so much for watching my presentation.